Hi, I'm Alex, and welcome to AutoProvisioner, your friendly neighborhood DevOps agent. Today we're going to walk through a quick demo of how to use AutoProvisioner. To get started, we can simply type in Start Demo. The next step is we're going to retrieve the demo prompt for utilizing Pulumi to deploy to DigitalOcean. Pulumi is an infrastructure as code strategy, and DigitalOcean is simply a cloud provider similar to Amazon Web Services or Google Cloud or Azure or any of the plethora of other cloud providers that exist out there. So to make sure that we keep going through this, I'm going to type in use defaults, but I will stop and back up very quickly. So what we're actually going to build during this demo is a DigitalOcean load balance set of droplets. Again, DigitalOcean is a cloud provider, and droplets is simply the DigitalOcean terminology for their virtual machines, i.e. the actual machines that they give to you as the cloud provider that you can then use to support your services and actually serve them to any of your customers or whatever it may be. So what we're specifically doing is deploying multiple web servers behind a load balancer. So this is simply a demonstration of what it might look like to deploy multiple servers behind a load balancer so that the load that is going to hit this service will be distributed so that it never overloads any single server. In addition, we're going to be doing some automatic NGINX installation so that we can see what's going on. As I mentioned, the load balancer distributes the traffic, and then we have some other good to have things within the DevOps world, such as resource tagging, and we have a nice production ready setup without too much complex configuration. So we're going to be using the defaults for this, just a couple of web server droplets, Ubuntu, the New York 3 region, and the cheapest droplet, because of course this is just a demo and we don't actually need to showcase a production usage of this tool yet, but that is soon to come. So I just typed in use defaults. If you want to change these settings, you can. If you're, for instance, using Windows instead of the Mac OS Linux environment, you can do that. If you want to change the number of droplets or region or droplet size or anything else, it's very easy to do. You just tell AutoProvisioner. So the step one, after we instruct it with use defaults, is the project initialization. So we're just going to make the Pulumi project. We're then going to read the Pulumi project file structure to see what was made after we just did that initialization so that we know what we have and we're not doing anything redundant. And then to operate within the DigitalOcean ecosystem, we can install the DigitalOcean Pulumi dependency. And then we write our main infrastructure configuration file. This is going to be in an index.ts file, a TypeScript file. The advantage of using Pulumi is it lets you write your infrastructure code in a general purpose programming language, which for some is very advantageous compared to Terraform or many of the other infrastructure as code strategies. But we support all of them regardless. So if you don't like Pulumi or you really love Terraform or whatever it may be, AutoProvisioner can do it for you. So here's the complete configuration. We have our NGINX index.html, we have our web servers, we have our load balancer. And then at the end, we export out the load balancer IP so that we can see the actual result of this completed demo. We are going to proceed. So what we're doing now is we're going to actually write this file. After that, we will continue with some of the other nice to have stuff, such as creating a README, and then we will validate the code that we've written and see the actual output. So right now we're running the write Pulumi configuration tool. This is going to actually write this whole index.ts file to the Pulumi project. Now we can update some of the configuration. We can say yes. So this is going to actually put the configuration that we discussed earlier in the first step within this Pulumi project. So this is the droplet count, this is the number of servers, again, that is going to be load balanced. We have our region, New York City 3, and we have our droplet size, the minimum size of the droplet, because this is a demo, and we don't actually need to get any large, bulky machines just to showcase this process. So next step is we're going through the README so that anyone else who may be working on or maintaining this project, should it be used in a real production company environment, is able to do that. So we have all the different steps that you need basically to get going. We have, of course, cloning down the repository, because this is all based within an actual repository, not just in the cloud consoles. We, of course, configure our credentials, deploy the infrastructure, test it, etc., etc. We have lots of extra information here, and then finally at the end we can just type proceed to keep going. Again, what's going to happen now is this actual README will be added to the project in our backend. One of the advantages of using AutoProvisioner is you don't actually need to set up a bunch of stuff in the background. One of the obstacles with utilizing current agentic tools is it assumes a lot about the environment that the agentic process is running in, such as already having access to GitHub or any other number of tools that are commonly used in the dev process. Now, while it's not such a big deal to install those, it does become a big deal whenever you talk about doing that at any sort of scale. We just want to really provide a seamless experience so that all of this can be managed in the background, and DevOps people can move on to the real challenging parts of working with applications, such as the architecture, security, anything else that is much more higher level and generally impactful for a given project. So we just wrote the README successfully. We are now moving on to validate everything. So this is very important in any sort of a agentic process, is actually validating the things that were written. It can be very easy for an agent to write some code, but then it doesn't really have any way of validating whether or not that code actually works, because it has limited access, if any access, to tools. Part of utilizing AutoProvisioner is we provide all of the built-in validation support and then provide that support to the AutoProvisioner agent as tools, so that the agent is able to confirm that the code that it wrote is actually going to do what it needs to do and not just error out and then kind of leave you with a mess. So what we're doing here is we just validated it. We saw that we converted the droplet IDs improperly in the first time. It expected numbers, but we were passing strings. So we just fixed that and rewrote to the index.ts file. And then we reran the preview Pulumi project tool, and we're all good to go. We successfully validated it. Now I will type in deploy now for the last step and go back for a second. So we successfully validated everything. What does that mean? That means that we know that this infrastructure as code project is going to do exactly what we want it to do. It's not going to error out for some unknown reason, because we successfully used Pulumi to validate that the code is correct. It's what DigitalOcean expects, and it's going to do what we want it to do, which is to create a load balance setup between two NGINX services. We see here that we have our resource configuration, and we have our tagging strategy and network configuration and outputs and everything else. If you want to clone down any of the code that is being written, i.e. copy down any of the code at any point whenever you're using this tool, that's always available. You can just say, give me the GitHub clone URL, and it will return that to you, but we don't need to do that right now. What we want to do is actually automatically deploy it. Now, this is possible if you provide AutoProvisioner with your cloud keys, which are all stored in a very secure, compliant way. This is going to basically enable you to, again, never leave this ecosystem and just have a really seamless experience whenever you're going through your normal DevOps or deploy to prod, etc. type workflows. Now, if we don't want to do that and we just want to keep everything on our own machine, it's also very simple to do the local development. As I mentioned earlier, you can just copy down any of the code that's being generated at any time through a Git repository URL. So you can have full control, or you can stay within the ecosystem and let it do everything for you, which I think is really convenient. Now, for the purposes of the demo, as I mentioned, we are doing deploy now. So that means that I've already provided the DigitalOcean API keys to AutoProvisioner, and it is now able to go and automatically deploy the infrastructure. So what we did is we ran apply PLM project infrastructure, the tool. We then got a job ID as the output. Now, what that means is actually spinning infrastructure up, or many sorts of different DevOps type processes, are more longer lived tasks that won't finish within, let's say, 5 to 10 seconds. Generally, doing this process with DigitalOcean specifically of applying the infrastructure takes actually maybe 2 to 5 minutes. 5 minutes if you have really bad latency or whatever. So for that, we just want to start it as a job in the background, and then we can continue to pull the job and see how the progress is going. So we pulled it a couple times, we see the output of the process, etc., etc. We're continuing to pull. It's going to probably take a little bit longer. We saw that we tried to pull for 60 seconds wait time, and it simply timed out, which is great. That's the same output as a wait call, so we can pull it again, and we see that we have the deployment complete. Wow, without ever having to leave AutoProvisioner, we were able to utilize this agentic DevOps to complete the entire process for us, of not knowing anything about how to use DigitalOcean or anything like that, to simply providing a key and then getting the output. We can see that we have a IP address, which is here. So this is going to be the load balancer. We can just navigate to this in Chrome. And wow, we see some HTML. I'm not really sure what all this is, but we see that we have web server 0, web server 1, back, forth, back, forth. So what this shows is it is being load balanced. So each request is going to the DigitalOcean load balancer and then being rerouted to either web server 0 dev or web server 1 dev, depending on the logic that's within the load balancer, which is a specific algorithm. Full demonstration of a complete load balanced between two DigitalOcean droplets setup using Pulumi and AutoProvisioner, your friendly neighborhood DevOps agent. Give it a try. Very excited to show you all what's coming next. Thank you.